What if I told you that every planet you've ever known, every spinning marble hanging in the black velvet of space, is boring, predictable? Spheres. Of course they are. Gravity demands it. It pulls everything equally toward a center of mass, crushing matter into the most efficient, least energetic shape possible, a sphere. It's cosmic law, written in the fabric of reality itself. But what if? It's the most dangerous and beautiful question in all of science. What if we dared to break that law? What if, by some miraculous, universe-altering fluke, a planet wasn't a sphere? What if it was shaped like a donut? This isn't just a whimsical thought experiment, it's a plunge into a realm of physics so bizarre, so counterintuitive, that it would redefine everything we know about worlds, life, and the very nature of reality. Imagine it, hanging there in the void. A torus, a cosmic ring, spinning silently. From a distance, it might look like a celestial wedding band, its sunlit side gleaming, the inner curves plunged into a profound darkness, the entire structure warping the starlight around it in impossible ways. The first thing you'd notice is the hole, the central void, a gaping maw in the middle of a world. What force could possibly hold that open against the relentless, crushing desire of gravity to collapse it? The answer is the same force that creates it. Spin. Incredible, mind-boggling spin. This wouldn't be the gentle rotation of Earth, giving us our 24-hour day. This would be a ferocious, planet-forging whirl. To form a stable toroid, the protoplanetary mass would have to be spinning so fast during its accretion phase that centrifugal force, the same feeling that pins you to the wall of a spinning carnival ride, would overpower gravity's pull at its equator. Instead of a sphere, it would flatten into a disk, and then, if the conditions were just perfect, the immense centrifugal force at the very center would push matter away, creating that hole. The entire structure would be a perpetual, violent tug of war between gravity, which wants to crush the donut back into a ball, and angular momentum, which wants to fling it apart into a scattered ring of debris. The stability of this world would be a razor's edge, a cosmic coincidence of perfect balance. And the sky? Looking up would be a different experience depending on where you stood. On the outer equator, the sky would be a familiar dome, though the sun and stars would trace dizzyingly fast paths across it due to the rapid rotation. But if you journey to the inner surface, the vista would be the most breathtaking and terrifying sight in the universe. The other side of the donut would arch over you, a colossal, curving wall of continents and oceans, mountains and clouds, stretching across the heavens. You could look up and see the lights of cities on the opposite side of the world hanging upside down in the sky. The planet would literally surround you. Day and night cycles would be chaos, with the sun rising and setting multiple times a day, sometimes even appearing to loop the loop in the sky as it passed through the hole. Timekeeping would be an arcane science. Weather patterns would be a meteorologist's nightmare, with colossal permanent storms likely raging around the zero-gravity band, and winds screaming through the donut hole in a perpetual torrent as air tried to equalize pressure between the sunlit outer rim and the frozen inner rim. The tectonic forces required to keep this fragile balance would be immense. The planet will likely be riven with constant earthquakes and volcanic activity as it strained to hold its impossible shape. And yet, within this maelstrom of physics, life might find a way. Perhaps in the calm, temperate bands between the chaotic gravitational zones, ecosystems could evolve that are utterly alien. Flora that grows in spirals to counter the shifting gravity, fauna that can fly effortlessly between the low G zones, or even creatures adapted to live in the weightless band, swimming through the air as if it were an ocean. Their entire perception of the universe would be based on a world that loops back on itself, where up is a relative term, and the other side of their reality is always visible, hanging there in the sky, a constant reminder of the impossible fragility and wonder of their home. So, is such a world possible? In the strictest, hardest laws of physics as we understand them? Probably not. The forces involved are too extreme, the balance too delicate. A toroidal planet would be inherently unstable over geological timescales. The slightest perturbation, a large asteroid impact, the gravitational tug of a passing star could upset the delicate balance between gravity and spin, causing the entire world to collapse catastrophically into a sphere or tear itself apart. But that's the true power of the what-if question. It's not about finding a definitive yes or no, it's about using that idea as a key to unlock new ways of thinking. By pushing our models to the breaking point, by daring to imagine the impossible, we learn more about the possible. We understand the subtle forces that shape our own spherical world with greater clarity. We appreciate the delicate equilibrium of gravity, spin, and geology that makes our Earth so hospitable. The donut planet, for all its apparent absurdity, is a profound teacher. It reminds us that the universe is under no obligation to be intuitive to us, and that the laws of physics, when stretched to their limits, can create realities far stranger and more wonderful than any fiction. So, the next time you look up at the night sky, at those pinpricks of light, remember, among them might not be a literal donut, but there are undoubtedly wonders up there that defy our imagination, worlds that will force us to rewrite the textbooks, and realities that will make a spinning ring of rock and water seem, by comparison, almost mundane. The cosmos is vast, and its possibilities are, for all intents and purposes, infinite.